random place to be.
Right? That's what I was thinking too.
I mean, that's dope, but it's hell.
I feel like let's just randomly go to Dubai. Yeah, like out of all the places.
Not today, buddy.
It smells like Costco with your burrito,
Is there a reason?
Tuesday. Tuesday. Bro, get out of here. 90 years.
Mickey, we need you.
Pro Babylon.
Chickens have water and everything.
That's great.
Yeah.
Will you please record? Sorry, will you please total all of the pre-response questions? So just use a red pen and write a single number very clearly.
Yeah. Are they already graded?
Yeah. And so I just want you to make sure that you take the time
Was there a dude I will? Zero. How does it work again? So how do I do that?
And I just cut them off.
These are numbers already here on the side.
verify that that's the right number of checkpoints.
I'm sorry.
You got all here just to make sure that everybody gets it.
Cut them off. I just wrote down one to close.
You got all of those. Okay. We're going to stamp 3.5 another day. Because I really have to get you all ready for the field trip on Monday. Since like all but 2 of you are going on that field trip. 3. TAs, you don't want to join us on the field trip? You are invited.
I'm down.
You would have to get me those papers with the packet filled out, and then you got to get your teachers to sign you out. Teachers have to sign you out by Monday, but I need the other one by today.
I haven't touched Monday, so never mind.
Oh, well, good. I hate it. Okay. Make sure that you've completed your warm-up. If you haven't, I can give you a few more seconds, maybe 1 minute.
These are all zero.
I believe so. You can see check marks anyway.
Okay.
All right. Let's assume that you have completed all that work. Like I said, 3.5 we will stamp on Tuesday. I'd rather focus on some preparations for the field trip. I have a couple of announcements first. Elena Khan, the woman who teaches marine biology, who's like a super nice lady, and the students seem to get along with her very well. So Elena Khan is going to lead 2 separate international trips over the summer. One to the Dominican Republic and one to Iceland. Some of you might know that she did a trip to the Galapagos in Ecuador last summer. Did anybody here go on that trip to Galapagos in Ecuador? I've heard from students who went that it was fantastic. They rave about it. She said they all had a really good time. And apparently this company that puts together the trips for the students, I am told that they have like a pretty aggressive schedule, that you pretty much come back tired and get to see a whole lot of different stuff. At least that was the case in Ecuador, Galapagos. It was her first trip, and she was kind of like, I don't know, I'm not sure, I can't say. And then everybody went and had a great time. But now that she's been, she's like all in. She's super stoked. She wants to go again. She's built 2 trips this summer, one for Ecuador, one for Iceland. Obviously, it's not cheap. It's not like you get to go for free. But technically, if you were planning a trip to go with your mom and dad to Iceland and Dominican Republic, it probably would be more expensive because they have some economies of scale, or at least it might be competitive. If you were going to do the same stuff, these prices are supposedly better because they buy for like 1,000 at a time. So I don't know, I'm supposed to just send you to her. She gave me some paperwork, but they ran out in first period. She's planning 2 trips. I think there's a cap on both of them, so you want to kind of like talk to her soon, and then she'll give you the prices and all that. I don't know the dates or prices. Yes? Yes, was your hand up there?
Yeah. Is it a community service trip or like what are they doing?
I don't think so. I think it's just like a cool science education tourism thing. It's like culture stuff and like whatever's notable. So in the Galapagos, they did all this like hopping around different communities in Ecuador, and then a bunch of like touring of the Galapagos, and they had like 3 or 4, like they were traveling every day. So they would like do something, go somewhere, do something, come back, do something, go to sleep. Same question? Anybody else? All I know is I'm supposed to send you to speak with her. And if you're at all interested, at least to find out the price and the dates, I would ask her right away, because it seems like now that she had a good reputation from the last one, student interest is far greater. Did anybody here know somebody who went to Ecuador, Galapagos? If you find those students, you should ask them. Apparently, like, everybody came back like super stoked. But whatever. Did anybody here go to yesterday's after-school environmental film? I'm supposed to wag my finger at you and take this as a warning, and everybody else should hear that I had 3 complaints about the noise last night. 2 from students and 1 in agreement from the adult when I woke up this morning to check my email. If this happens again, I cancel the series. Everybody who was there, maybe you know who was being loud. Tell all your friends it's their fault. Tell all your friends, those people who were talking during the movie, they're the ones that ruined it for all the rest of the students and apes. It's a lot of point potential. When you're there, if you see kids talking, remember, they will take the points away from you. You can ask my students. I canceled it for about 3 weeks last year. Then I was eventually convinced to turn it back on. This is such a hassle for me. I'm just looking for an excuse to stop. Field trip plan is Monday, 8:15, flagpole, backpack, food, water, layers. Comfortable shoes and adequate sun protection will be outside the whole time. If you have fair skin or never go outdoors, you might need to bring your own sunblock to reapply. Weather looks pretty warm and sunny on Monday, but you still want layers for the morning because UCS Brodog has like some pretty dynamic weather. Remember, you have to bring your own food and water. Are there any questions about the field trip on Monday? Last call for questions. It's going to be really good. I'm super psyched. Yeah.
Never mind.
Ask.
It's okay.
Come on.
I was gonna say, what are we doing? But I'm sure I could get the answer from someone.
We're going to go see habitat restoration sites, and we're going to go see ecological succession. So a lot of the stuff that we talk about today, and it's generally germane to our unit.
Got it. Thank you.
How many students are going?
I was kind of shocked to see that almost all of them. I've got 2 students staying in period 1 and maybe 3 staying in this period. And in most of my, period 5 had really bad turnout. I don't know if I forgot to collect the papers or something. But all the other, there's like 2 or 3 kids left from each period. Okay. We skipped or rather we still haven't discussed the aquatic biomes, but that's part of what I'm skipping so that we can prepare for the field trip on Monday. I want you to take out your 3.4 and 3.5. I'm going to try to do both in one day.
I have a no name one, but I just go.
No name at all? Leave it in the period if you can.
It doesn't even have a period on
But it's in a folder, right?
Yeah.
So just put like the period question mark, like 3 question marks.
And they got like a real system.
Alright. We're going to try to do 2 whole assignments today, or at least most of them. I'm going to go pretty fast because honestly I think there's just like 2 things in 3.4 and then like 2 things in 3.5. And in order to go really fast, I might sort of backward and forward a little bit. 3.4 vocab questions, go. Thermodynamic systems are anything which has change in energy. Thermodynamic, energy change. So you are a thermodynamic system, and your car is a thermodynamic, and the Earth and the universe and the sun and basically anything that does anything. Yeah. Is disorganized or low quality energy. It's chaos. Yeah, disorganized energy. Low quality energy. Yes?
Can you give like an example?
Well, no, and it's one of those weird things where like
I have no idea.
I know, right? And like in study goal number 21, tell me if you're satisfied. So when we do 21, I mean, when we get to 21, if I can define entropy, great, and if not, tell me again. Yeah.
Is the energy just like left over and that's why it's disorganized, or is it like unused?
We should do this in 21. I promise. Let's say, I mean, like, these are good questions, but like, either we just do 21 right now. What are the two laws of thermodynamics? Let's do 21. What are the 2 laws of thermodynamics? You probably know this from another class, not necessarily from your book. Yes?
Law 1 is energy can be neither created nor destroyed, and law 2 is in all energy exchanges, if no energy enters or leaves the system, the potential energy of the state will always be less than that of the initial state.
Yeah, those are very wordy ways to say it. I can give you the most memorable generic ways if you want help, but those are both perfectly accurate.
Yeah.
The way that I always heard it, or rather the way that I always wrote it in my notes, so I remember this perfectly, energy is neither made nor lost, it just changes form. That's number 1. In the entire universe thermodynamic system, energy is never made, it's never lost, it's just changing. From one type of energy to another type of energy. And we've got a whole unit coming up at the end of the semester about this topic. So for now, the basics, energy neither made nor lost, just changes form, is the first. And second, in each of those transformations, quality is lost. When energy changes form, quality is lost. And what we mean by energy quality is how concentrated it is, how much work it can do.
Since energy is always going towards like a less useful form, do we have a finite amount of it? Or can we
Yes.
just change it by?
This is the part that's kind of mind-blowing. So I'll see if I can. I'm going to talk around your question for a while, and then I'm going to try to come to your answer. Our current Newtonian understanding of the universe is energy is neither made nor lost, it just changes form. This is just like Isaac Newton, right? Is Newton's law of thermodynamics? Is it Newton's law? I mean,
Yeah.
are they Newton's laws of thermodynamics? Katie, Newton's laws? Somebody Google, but I think so. The most basic understanding of the universe is it never made, never lost, just in its form, which means you use energy to do something different and get a different kind of energy. Nobody can generate energy. So like, oh, but a wind turbine makes electricity. Yes, out of wind energy. I don't know, well, dynamite makes the bomb. Yes, out of stored chemical energy.
And so the sun has like a limited amount.
So the sun has a limited amount, and the planet has it, and the universe. There was a time when all energy was super high quality. The split second right before the Big Bang. That's what bang did. All that energy goes into kinetic and chemical energy, you know, tons of heat and stuff, the universe expands, it's like, whoa, bam! And everything is burning up, getting used. You all know that stars die eventually? That's when they run out of energy. They go. Maybe they become black holes? Is that how it works? I don't know.
Rutherford Clausius and William Thomson.
Really?
Yeah.
What's Newtonian thermodynamics?
It's like an object in motion stays in motion.
Oh, crap.
You're probably right. Wait,
Yeah.
it's like Newton's like 33 law.
Those are laws
And
of
like the
physics.
law of
So.
inertia. Yeah, it's like
Yeah.
Oh, that's it.
Well, maybe I fumbled my Newton, but these go way back. Here's the crazy part, though. The thing is, if all energy is going downhill in quality, just kind of like fizzing out into wasted heat energy, then sooner or later the universe dies. Yeah.
You were right, they're called Newton's laws, but they weren't made by Newton.
Aha! Redeemed by me. Thanks, buddy.
You're welcome.
This is like Darth Vader does something nice at the end, so he's redeemed.
Yeah.
I taught my children what redemption means by watching Star Wars. So you see, but he saved his son. So I had the Darth Vader costume for Halloween this year. For Toby's birthday, I wore the costume and I came out and tried to heckle all the kids, and they all had lightsabers, and so they attacked me. And we had this like videotaped assault by 24 5-year-olds using little foam lightsabers to kill Darth Vader underneath the pinata. My life is a total joke. Start to finish. The universe is going to run out of energy. It's fizzing out. It will eventually go. And when there's no more expansive energy and there's no more anything to be done with any of it, then the question is, what happens? And either the universe dies and that's the end of everything, or the competing alternative is gravity takes over and all that wasted dust just starts gravitationally pulling against itself, and gravity provides enough compression to theoretically reset the energy thing, and then Big Bang happens again. These are the two possibilities.
Maybe there was already a Big Bang. It was already a world.
I know! Like, this is the whole, like... We are basically just irrelevant though, so we don't have to know this. I mean, we probably could benefit from knowing all sorts of stuff, but don't worry about it. All life will die on the planet long before the planet gets sucked into the sun, long before the sun runs out of energy, long before the universe runs out of energy. So you got much bigger problems than the solution to this question, but okay, fine. What's the difference between primary? Entropy is that disorganized energy, by the way. The perfect example of of entropy is like dynamite can do all this stuff. Wow, and it goes boom. And then you've got all this stuff moving really fast, so there's still energy, like all the rocks going into the air, like the body parts. And then they all hit the ground, and then the dust settles, and then it's just like, well, I guess it's over now. And it's just like dust and warm spots. That's entropy. You've gone from super concentrated energy potential, which is chemical potential energy inside the dynamite, to kinetic energy, which is like all that expansion and stuff and all that heat. And then you get the entropy, which is just like, now what? You've spent the chemical potential to make kinetic that eventually ran out, that just gave off heat. Entropy. Energy, like once you just have heat, then it's like, no, now what are we going to do with that? That's entropy. It's chaos. It's like the disorganized energy of the universe. Does that kind of answer entropy? Yeah. Anybody else want to ask me about this? Because I have no idea what I'm talking about. I made all that up. Yeah.
Is it correct to say that as a system disorder increases, entropy increases?
Yes. Entropy is that disorder. Yep. That's like as the lights go out, dark increases. Anybody else?
So when energy is like lost in a system, where does it go? It's like you're not heat.
Dissipates. It disconcentrates.
It just goes away.
Yeah, it deaggregates. It just spreads out. It fizzles.
Is it like a battery losing its power? Almost.
Yeah. Which, by the way, gives off heat. It is when the battery does lose its power, all you get is heat out of that. It's like your headlamp makes all this light, and then that light can hit stuff that makes heat, and the thing will heat up because it's using up the. And it's like no more light because you just transformed all that energy into heat. Either heat up the device or heat wherever the light hits something. Yeah.
Is there like a reason that we're talking about entropy? Is there like a use for it, or is it just like a side note?
This is like an esoteric question, like why do we talk about zero when we talk about numbers? You can't do energy conversation without realizing that energy is lost as heat. The entropy is not necessarily the goal of our conversation, but you can't have the rest of the conversation without knowing what happens to the waste. Yeah.
So since energy isn't created or stored, it basically like its last form is heat. Like that's like the stored.
Yeah. So all energy goes from high quality to low quality. That's the second law, which is really just an outgrowth of the first one. Anybody else? Great. Back to the vocab. What's the difference between primary and secondary productivity?
Primary is by autotrophs. And then secondary.
Yeah, primary is by autotrophs like plants. And secondary is by things that eat, like you and me and cows and chickens and crickets and mice. So now some study goals. Number 18, we measure that productivity in a lot of ways, but essentially what we want to approximate is how much energy are we talking about. So primary productivity, sunlight is used to build sugar compounds which store energy, right? We talk about that? So how do we measure that energy? You can measure it in pounds of life, called biomass. You can measure it in organic carbon bonds, called biological production. You can measure it in calories, called energy storage, or you can measure it in carbon atoms, called carbon storage. I don't care which units you use, there's a lot of ways to talk about energy stored in production. That's number 18. Did you ask a question, Tim?
No, I was
Got it. Number 19. Could somebody please answer these study goals for me? These study goal? Truth is, I actually eat a lot more than 3,000 calories a day. I have like a really freakish metabolism, and so I eat like unbelievable volumes, and then I poop unbelievable volumes. Pretty much if I go an hour and a half and I haven't eaten, I get really cranky and I start to bonk and my stomach hurts. I eat crazy, like probably 4,000 calories on a rest day. When I crank up for summer metabolism, like I literally eat more than a bear preparing for hibernation. Like I've measured. I don't know how that works. Maybe I'm dying. I kind of imagine like my digestive system as like this perfectly slick PVC pipe that doesn't do its job. So it's just like, come on, I gotta get something out of this. And my body's like, nope.
Maybe you have an insane piece of tape on it.
I know, right? But they'd be somewhere. The other thing is my wife has a theory that there's like something tweaked with my metabolism because I run really hot. And my theory is I just transform food into body hair.
That would be unfortunate.
I found like a big old dark hair on my earlobe the other day. That was pretty exciting. Yeah, I'm a hair making machine. So, for the sake of conversation, let's say that I only ate 3,000 calories yesterday. Does that mean that a shark who eats me today will get 3,000 calories over the shark that could have eaten me yesterday? Could somebody explain to me why this is?
Because some of the energy that you ate.
Alexia, raise her hand. I like that.
Isn't it because I could be wrong, like only 10% of the energy gets transferred
Transfer to what?
to what's eating?
What you said is a generalism that's accurate, but why do I not? Want to raise your hand? Good. Shut up then. Yes, Ms. Carter?
Because we use the energy, so it's not going to become stored energy.
That's right. Yeah, I use that energy. I probably won't store very much of it at all. On an average day, most of what we eat is basically just maintenance. I use that energy to replace lost muscle cells, to sprout hair, to yell and run around and chill with your mom. Takes a lot of energy. Whatever I do on a day-to-day, that's using up all that energy that I took in. We go through different phases metabolically in our lives. So little babies, they do a lot less, but they grow a lot more. Old people grow very little and do very little, so they need less calories because there's very little left to maintain. Maybe if I blind you, you won't need your phone anymore. What do you think about that? Could somebody get me one of those good green lasers that actually blinds people? Great, thanks, I mean.
I brought one in last year.
Yeah, I do. And so there's terminology for this. We call it gross production, like how much you actually digest, or how much a plant actually makes. Minus respiration, aka usage, is how much you have left in the bank. A lot of ways to say this. So income minus expenses equals savings. Yeah? I made $10, I spent $9, I saved $1. Or, please look up, I eat 2,000, I use 2,000, I gain no weight. The paradigm, the basic fundamental. What you got? Good artworks? The basic fundamental of diet theory.
It's a Jose whale.
Nice. We gotta save that one.
Yeah.
That's beauty.
It's like Jose's a whale.
The basic, I love drawings of me.
You got a couple like
I
Jose
did.
on them.
I did do.
Yeah, I drew
You know those
I
things.
drew you on a whale.
Yeah, keep it coming, keep it coming.
I drew you fishing.
Wicked.
You see,
I posted this on my book face. There's 2 Jose on whales. I love them. Anyway, here's like
Still my idea.
the basic idea, the one that people like tell you most often that you've probably heard is if you eat more than you use, you gain weight. And if you starve yourself, taking in less than you're using, then you're going to use up some of your stored. The terms for this are net, gross, respiration, or usage. Okay? And you can expand this further. I'm going to skip around. Actually, I'm not skipping around because we already did this. How efficiently you do that, the ratio of input to output, changes in your life. Remember that you went through a phase as a little baby where you were highly efficient at storing energy, right? Now you're at a phase where you're pretty efficient at using your energy. So you can be more active, but then you'll get old. And your energy efficiency drops, so your food intake usually drops. If you average your input to output ratio, you can figure out your conversion of food calories into person calories over your lifetime. And we can look at a whole ecosystem that way. I'm going to try to make easy numbers. Let's say that we have 1,000 calories of grass. That's just like growing in the field. You can't get more water, you can't get more nutrients, so it'll pretty much be 1,000 on average if grass is doing what grass does. Oh my God.
Just hold on to it.
I mean, break his phone.
You're breaking it, I'll hold it.
Break it. Give it to Amin right now. I mean, if it makes any noises, smash it against the wall.
I wish I would.
I wish you would too.
Kick my ass.
I find that I seek up for you. Okay. So we have, let's say, 1,000 calories of grass. And the crickets are out there. Crickets, let's say, eat grass. Will a constant population of 1,000 grass calories make for me a constant population of 1,000 cricket calories? Yes or no?
No.
No, why not?
Because I get 10% of the extra use. Because it's mostly used.
Cricket's going to use some calories, right? It takes energy to be a cricket. They got a lot of hopping and chirping to do. So, please look up. Of the energy that went into the crickets, most becomes metabolic heat loss, which, if you think about it, is exactly what I'm doing. Because, you know, yelling at you and chilling with your mom, that stuff makes me sweaty. And you know that if you do more things, you're going to get more sweatier. Like go run stadiums, you realize you will make much sweats. And if you spend more energy, so there it is, right there, the metabolic heat loss. So the crickets would be, let's pick a nice, easy number, a smaller caloric potential. And then mice which eat crickets, of course, they're going to spend most of their intake too. So that ecosystem will probably have somewhere less. And then the hawk will probably have even less. And there's great variance Two of you already pointed out that the global average oh my god. Average trophic efficiency is about 10%, roughly-ish. So in any ecosystem, do y'all remember the shape that I showed you at the food web where we talked about how many you need and how many you need and how many you need and what predators or indicators and all that? There's a reason I showed you that shape. That's not an accident. This thing's called a trophic pyramid. How much productivity is required at the bottom to create how much caloric content at the top? This is kind of basic, right? You all look pretty bored. One last question and then we move on from this assignment. If Jose has 1 acre of farm, which produces, for the sake of conversation, 100 calories of corn. And we know that's wrong. But 100 trillion calories of corn, whatever, I don't know. 100 calories of corn in my acre. What would happen if I used my acre to grow corn to feed cows to eat cows?
Wait, what?
Yeah.
To feed
Look, I got an acre that makes 100 calories of corn. Can we agree on that setup? Follow with me because it's about to get complicated. 100 calories of corn per acre. I could just eat the corn. You all realize that humans can eat corn, right? Or I could use my acreage to make corn that instead of going into my belly will be fed to livestock like cow that Jose plans to eat.
Would you get 1 calorie from the cow?
10% is 10, but yeah.
No, I would get 10. And then you would get 1.
Oh yeah, right, yeah. So I would either get 10 from the corn or 1 from eating the cow. Can anybody explain this to me? Yes?
You'd be wasting your corn because then the cow uses some of the energy from the corn and you could have just ate the corn in the first place.
Yes, the cow is a waste of energy usage. We could have used the calories that the cow would use running around and mooing and doing whatever cows do, leaving you very little for your own running around and mooing.
But it tastes better. You can just get like
Sure does. Sure does. And you and me, we can eat whatever the F we want because we can afford it. I mean, I don't know about you. I can afford as much meat as I can possibly consume. I'm trying. But globally, this is a very interesting question. Every plate of steak you eat is 10 plates of veggie food that 9 other people could have shared with you. In terms of terrestrial footprint, trophic efficiencies, how much land we have on the planet. And BITD, when there was plenty of land available for food, this wasn't a big deal, but you all realize that we're basically out of land to make food, and we got more and more people every day. And by the way, as the global economy develops, more and more people are eating more and more meat, meaning that the poor have a smaller and smaller and smaller wedge of the landmass to make their calories with. Does this make sense to everybody? Trophic efficiency implications on food choices? Okay, well I'm glad. That's very nice. Oh, 20, 21, 22. I am done with assignment 3.4 unless somebody has a question. Ask it now if you do.
You're not gonna go to 21.
Oh, 21 we already did. Remember we talked about the 2 laws of thermodynamics and then I gave you a working definition of entropy?
It wasn't 21 about like
Oh, maybe I missed
all
something.
eating its own like
Oh,
speed.
okay.
Oh yeah, that's
All
just
of
like